For this second lecture, Friday, April 24th, this will be a short lecture. I'm just going to talk about major fishing areas. And then for Monday, the last day class, April 27th, we can talk about topics number 5 and 6, improved management in the future. Now, in terms of major fishing areas, you guys, having taken a marine biology class this whole semester, having learned a lot about the environmental conditions in the ocean, all this primary productivity, and having a lot of knowledge about marine organisms as well as the ocean itself, the physical, chemical, geological conditions within the ocean. You guys have very good information, very good knowledge about where to expect major fishing areas to be, because you know where marine resources are and how they're distributed around the world. In the ocean, you know what marine ecosystems are especially productive and which ones aren't. So that's what we're going to focus our attention on. And as I said, this is not going to be a very long lecture for this second lecture. Not surprisingly, I'm sure it's not surprising to you, that the major fishing areas are close to shore. They're above the continental shelf. They're in estuaries. They're in areas where there's a lot of upwelling. Even some of these international fleets do a lot of fishing along the continental slope, where the continental shelf ends and the continental slope starts. And that's sometimes relatively close to shore, so it's in the economic exclusive zone, the EEZ, of different countries. It belongs to waters of different countries, even the pelagic areas. Now, there is pelagic fishing far offshore out in the middle of nowhere. But let's look at these different areas. In terms of coastal areas, of course, there's a lot of nutrients from land, from runoff. It's shallow. There's a lot of sediments. The distance from the sediments where all the nutrients are up to the surface where all the primary producers are is not very far. Or the primary producers are actually in shallow water, like seagrasses, salt marsh grasses, or mangroves. There's a lot of energy, a lot of photosynthesis takes place. Now, we've also seen all of that primary production might not enter into ecosystems by those plants being eaten. However, they do provide a lot of energy, and they enter into these ecosystems in the form of detritus. We saw again and again and again in these different types of flowering plants. So the other reason why coastal waters are so productive is because it's shallow. There's a lot of light. Light is obviously required for photosynthesis, primary production. So there's a lot of production there. That's one thing. The other thing, of course, is that it's close to shore. It's easy for us to access. So we've been taking advantage of this for thousands of years. As long as you had a boat, little canoe, some kind of fishing access to fish offshore, we didn't even have to go very far. We could go out and access coastal fish resources. And even today, when you're looking at the different regions of the ocean, different geological features of the ocean, one of the things pointed out was that the continental shelf represents waters above the continental shelf. Anyway, represent not a very big fraction of the total water of the ocean. It's only about 8% of the total ocean area. But if you add up all the different fish, all the different invertebrates, all the different harvest from the ocean, that's about 90% that comes from these continental shelf waters. So it's a combination of those waters being really, really productive and, of course, close to shore with easy access by humans. So it's not just fish, but there's a lot of other things that are harvested. Here off the Rhode Island, you go out in the waters off of Rhode Island, out by Block Island or offshore a little ways. Even if you go to the ports, like Galilee or Jerusalem, Point Judith down there, you see trawlers. There's trawlers all over the place. And Rhode Island has a lot of trawlers. So these trawlers, they go out there, they lower their nets, and they drag their nets up and down on the bottom. A huge amount of the bottom. They try and restrict the areas where they're allowed to trawl these days. And some of it is there's rocky parts of the substrate, not very good to drag your trawl across. But there's a huge number of trawl fisheries that are going along, scraping the bottom, either looking for fish or scallops, invertebrates. And so it's a big fishery, very common off the coast of Rhode Island. If you went out in the summertime, you'd see trawlers out there all over the place. Another part of the ocean, somewhat related to these coastal areas, continental shelf waters, is upwelling areas. Now, some of these aren't above the continental shelf. Some of them are equatorial waters or other places where it's a lot deeper. But there's certain conditions that lead to upwelling. There's offshore winds that take the water out, or longshore winds that remove the water. Then what you have is the water below is brought up and replaces the water that's removed by the wind. And you have upwelling. And with this upwelling comes a lot of nutrients. And so those nutrients are available for phytoplankton, lead to a huge amount of primary productivity. But if you go around and look around the world where these areas are, where there's all this upwelling, it's not just all along the continental shelf, but it's in areas that are especially good for phytoplankton and zooplankton and things that can filter feed on zooplankton. So around the world, if you look at the west coast of the U.S., sardines play that role. If you look on the west coast of South America, anchovies and anchovettes play that role. If you look on the east coast of the U.S., there are minnows, there's different herring as well, and one of the things that we have very prominently that's taken advantage of this, it's not such an upwelling area, but where there's a decent amount of primary productivity and they operate in the same way, are menhaden. Off the west coast of Africa, pilchards are these little filter feeding fish. And so we also saw earlier in the semester why the way that the ocean gyres work and the water that's coming down from the cold versus coming up from the south, coming up from the equator with warm water, that lead to these upwelling areas and lead to these very productive areas that tend to be off the west coast of continents. So off the west coast of North America, you've got these sardines. Off the west coast of South America, you've got these anchovies. Off the west coast of Africa, you've got these pilchards. Those are very productive areas, huge amount of fishing, and pointed out the extent to which those fish contribute to the total amount of fish that are harvested from the ocean. Then you have these pelagic areas that are basically the rest of the ocean, widely dispersed. There's a lot of fish that are out there that travel around. Now these fishermen have very predictable routes that they take, areas that they fish. They're looking for certain conditions, and so they're looking for upwelling. They're looking for fronts where two bodies of water move past one another. They're going along where the continental slope starts. The continental shelf drops off steeply to the continental slope. There's a lot of international fishing going on, international fleets. Some of this water doesn't belong to anybody. So they're out there doing whatever. No one's even monitoring what they're doing. There's a lot more monitoring of where they are these days, although that depends on the country as well, how well that's enforced. So if you look around the world, these areas in the red in this map show these areas that are very productive in terms of phytoplankton, and very productive in terms of zooplankton eating the phytoplankton, and very productive in terms of things eating the zooplankton. Think about the number of steps to get to a fish that we're eating. 1, phytoplankton. 2, zooplankton. 3, sardines. And then you're eating them. That's 3 trophic levels. Pretty minimizes the amount of energy that's lost each step of the way. If you're talking about phytoplankton 1, zooplankton 2, herring 3, and then something like a menhaden, or not a menhaden, but a mackerel 4, and then a tuna 5. That's 5 steps instead of 3. And so eating a tuna, of course, is a lot less energetically efficient in terms of an entire ecosystem. We look again at the west coast of the continents shown here, the west coast of the US, west coast of South America, the west coast of Africa. Those areas are particularly productive. If you contrast that with the east coast of the US, there's some areas that are fairly productive. A lot of the fishermen go up to Canada, up off of Nova Scotia and Newfoundland, Georges Bank, the Grand Banks, up there with a lot of fishery. People have been coming over there for hundreds of years. Even before the Pilgrims arrived, people were coming over to the Grand Banks and fishing for cod. Years before 1620, coming over from Europe and off the west coast of Africa. You can see the difference between the west coast and the east coast of Africa. So this is where a huge amount of fish, not just bony fish, but shellfish as well, invertebrates, are harvested from the ocean. These areas that are red on this map. And as students in a marine biology class, you could explain to somebody pretty well why the areas that are so red on this map are located where they are. You know about the environmental conditions in the ocean, upwelling, and how the currents move, as well as the type of organisms you find there, and that you know about the continental shelves and continental slopes. So explaining a map like this, you could do pretty easily. You can understand compared to somebody that hasn't taken this class. So this is a good place to stop for this Friday. And on Monday, we'll talk about 2 other things and finish the course talking about improved management, or just management in general, and then the future. What does the future hold as far as exploitation of marine resources?